Okay, in this video, I'm going to do an update about the Mixtral of experts. So basically today we have a blog post out a few hours ago, and also looking at some of the code earlier on today, I realized that my diagram wasn't that good. So I want to go through and explain a little bit more of how they're doing this with a transformer version of the Mixtral of experts. So first off, the blog post is out and it goes into detail about what they've actually released now. So we've got a lot more than just a simple torrent link. We've also got another model out just in the past few hours as well. So what they talk about in the blog post is some details about the model. Obviously, one of the sort of major details is that it matches or outperforms GPT 3.5 on most of the standard benchmarks, as we can look at in a second. The other thing too is that it's got details a little bit more about the languages that it supports, being English, French, Italian, German, and Spanish. Unfortunately, no Asian languages or other languages apart from these. And it's also got a lot of the details about the actual model itself. So not surprising, this is a decoder-only model. The thing that is different than what I explained in the last video with some of the diagrams is that what they're actually doing here is they're sharing key parts of the decoder network. And they're actually having the sort of experts in the feed-forward blocks. So at every layer, they have these router networks that basically choose two of the groups of experts to process the token and then combine this. So this is a diagram showing this concept from the switch transformer, which I talked about in the last video. So you can see that you've got the normal self-attention going through of a transformer. So we've got the normal parts of the self-attention and the mask of a decoder, part of a transformer going on in here. But then when we get to the feed-forward layers, you get this router system going on where it's going to basically have the experts go through this. And then they join back together and go to the next layer where, again, they share the self-attention and split up for the various experts as it's going through this. So the concept of thinking of it as being 8 times 7 billion is a bit misleading. So actually, the Mixtral has 45 billion parameters in total, but it's only using 12 billion parameters per token. So therefore, you're getting the advantages of having the big model, but not having to use that and for actually doing the compute and processing it for generating out here. So they mention here that the model processes input and generates output at the same speed and cost as a 12 billion model. So for less than double the size of the compute needed for doing the inference, we're able to get a model that's much better performance here. So let's have a look at some of those performance stats. So a quick shout out to Vikyat and this Git repo for Mixtral inference in here. You can actually look at the code of how this is basically being done and see that, okay, what is actually going on with these feed forward layers and how it's actually gating things out and then taking the top 2 experts from this. So this is a good repo to study if you want to see how this is done as well. So you can see here that they compare to the Llama 70 billion model, and they're far smaller than that, even with the 45 billion parameters here. You see on MMLU, it's not only beating Llama 2 70 billion, but it's also, and on most of the other benchmarks, they're also either beating GPT 3.5 or coming very close to matching it in here. So one of the cool things that they've also done today is just release, literally a couple of hours ago, a instruct version of this model. So previously they'd released the base model. The one I showed you yesterday was releasing the base model. This is an instruct fine-tuning model. It's also used DPO for direct preference optimization here with this. So personally, I think this is a really good vote for DPO. The fact that this team really seems to know what they're doing. They've produced a really good 7 billion parameter model. Now they've released this mixture of experts model, and they're also using the DPO on here is a very interesting sign for this. Another thing that's interesting in this is the MT bench score. So this is the multi-turn bench. It's basically testing that will the model be able to have a conversation going back and forth over multiple turns here. And it certainly does, which is really good to see here. Another thing that I find really interesting in this is that they haven't tried to dumb this down or anything, meaning that they don't seem to have censored the model. They do give you some things that you can do if you want to have a stronger version of moderation, etc. here. And they also mentioned that you can actually do your own preference tuning for, rebuttals or things like that going through. And finally, they finish up basically talking about that they've released code. So they've submitted code to VLLM, which actually allows you to run this model for both the base model and the instruct model in the VLLM in here. So my guess is probably just a matter of hours or possibly a day or two before we have a quantized version that people will be able to run on a smaller GPU. You could imagine that the quantized version should perhaps be able to run even on a T4 GPU going forward. So this is certainly going to be interesting to see how this instruct model performs over the next few days here. Hopefully this clears up some of the issues that I had in the previous video, and that people have a better understanding of exactly what the model is doing here. And hopefully over the next day or two, we can all play with the instruct version of the model. As always, if you found the video useful, please click like and subscribe. I will talk to you in the next video. Bye for now.